right, in number 8, they're asking, is there an association between the method of delivery and the ethnicity in the following data? It represents thousands. In the thousands represents the method of delivery in the ethnicity of mothers who had a baby in 2005. Okay, here's the data that they gave you. The first question is how many births, so the total births in 2005. Well, that would have to be 3,834. Well, remember this is in thousands, so we're talking 3 million, well, let's see, thousands, let's put it like that. So we have 3 zeros on the end of that. How many births had Hispanic mothers? Well, the Hispanic mothers is going to be this total here, 983,000. Part B says construct a relative frequency, so that's what we're going to do next. Now I rewrote the table again. That's where Excel would really be nice. I'll try and put one on Excel and attach it to the Google Drive so that you can see it. Now what I'm looking at doing here is what I want to do is I want to take the total. So remember the total was 2270. So what I'm looking at doing is taking each one of these. So the relative frequency is found by dividing the row total by the table, and the relative frequency for vaginal delivery is going to be 2670 divided by 3834. So 2670 divided by 3834, and the relative frequency marginal distribution for the column of ethnicity is found by dividing the total of each column, and so if I want to, I can then go. Alright, so what I did here was I took the total of this column divided by the total of this column to get this relative frequency. The total of this one divided by the total to get this frequency. Same thing that with down here. I took 2270 divided by 3834 to get this, etc., etc. And these two added together better equal 1, and these 3 added together better equal 1. Now if they ask me what's the proportion of vaginal births in 2005, I've already got that answer. Vaginal births, this is the total, so it's going to be 0.696. is the proportion of vaginal births in 2005. Okay, now to get a conditional distribution of delivery method by ethnicity. So what we're going to do is we're doing it by the ethnic background. So we're going to take 1580 divided by the total, and that's how many proportions are vaginal. So we'll take 1580 divided by 2270, which gives me 0.696. I take 690 divided by 2270 and get 0.304. That total better equal a 1. And then I'm going to take 392 divided by 581 and get 0.675. I'm going to take 189 divided by 581 and get 0.325, and again that total better equal 1. And on the Hispanic end we have 698 divided by the total, which is 983, and I get 0.710. Then I get 285 divided by 983 and get 0.290, and again that better equal 1. There is my conditional distribution by method of conditional distribution of method of delivery by the ethnic background that we're talking about. Now I've got this chart. I've got my relative frequency, the ethnic background, and yes, I should write this out. It should say whites, it should say blacks, and it should say Hispanics. And I'm going to take these values from this chart, and I've got to have them by delivery method. So if I look at 0.69, it goes right about almost to that point. And I'm going to make this all that color. And C-section was about 0.3. And if I look at the black community, it's going to be a little bit less than the other one. And the C-sections is a little bit more. And then if I look at the Hispanics, we get up to 0.7. And then just under 3 for the C-sections. And that would be a bar chart of a conditional distribution. Number 14, we're looking at kidney stone treatments. Researchers conducted a study to determine which of the two treatments is more effective. So they had 273 people that it was effective, 77 that it was not. And this is a table of values that they gave you. So we want to know which one appears to be more effective. So let's look at just the effective. We're going to take 273 divided by 350, that's treatment A, and we're going to find out that the proportion of those is 0.78. Now let's look at treatment B. Treatment B is 289 over 350, and that one ends up being 0.826. So right now, the one that looks, the data implies that treatment B is more effective. That's what the data implies so far. All right, now in this one, where the data in the table does not take into account, this data up here, does not take into account the size of the kidney stone. So in this table, they actually looked at the effectiveness on both small and large kidney stones. So in part B, they said determine the proportion of small kidney stones that were effectively dealt with using treatment A. And then determine the proportion of the small kidney stones that were effectively dealt with using treatment B. So what we're going to do with treatment A, we are going to actually look at treatment A. It would be 81 over the total here, which is 87. And we get 0.931. And then the proportion of kidney stones that for treatment B, we're going to say the total here for treatment B was 270. So now we're going to say 234 over 270, and we get 0.867. So which one was more effective? Well, it looks like it might have been treatment A, while this one up here says it's treatment B. Part C, we're going to do the same thing, but this time with the large stones. So when we look at, we repeat the procedure for part B using the large stones, and then what we're going to do is organize it in a table. Okay, so for part B, what we have here, or part C, what we're going to do is we're going to now do the same thing for the large stones. We're going to take the effectiveness of 273 over the total here, which is 10, 15, 250, and we're going to take the effectiveness of treatment B, which is 55 over, let's see, 1080, and what we will end up here is that this ends up being 273, no, this is 350. So what we end up here is 0.78, and here we end up with 0.688. Now part D is drawing a bar graph, and then E is reporting what we found. So this is what here's a bar chart, and keep in mind the treatment A had 0.931, so if I'm looking at the small, we're going to be a little bit over here, treatment A. And then treatment B for the small was 0.867, so it's a little bit less. And then for the large, treatment A had 0.78, so it's just a little bit under the 0.0 or 0.8. And treatment B had just a little bit less than that. So that is your bar chart for those two different treatments. Now when we look at E, E says, can we draw some conclusions? Well, it looks like the direction of the association reversed after we looked at the size of the stone. In the beginning, we saw that maybe treatment B was more effective, but now it looks like treatment A works better. And you would summarize that with complete sentences. So the association was reversed when we looked at the size of the stone, and as we looked at the size of the stone, treatment A was better.